Hi, today we are looking at section 5.3, which is an introduction to composite functions. So if composite functions, we're essentially inserting one function into another function where its variables are. So when dealing with a table of values or graph, how we do this is when we find the y value as specific x value for one function, we then substitute that y value in for the x value of the other function. Now, if there's two ways to write it out, we can write it as y equals f bracket g bracket x bracket bracket, or f of g bracket x. Both of these stand for f of g at x. This would be f of g at x. This would be f of g of x. Okay, so this example, we have two table values, one for g of x, one for f of x. And we want to determine f of g of 1 and g of -1. So we'll utilize these tables to do that. So we'll start with our inner function. So this one's inner function is g of 1. This table has our g of x. So we look at where x value is 1 and we get 2. So if we're looking for f of g of 1, what we're really looking for is f of 2 because we've determined g of 1 is equal to 2. So if we are looking for f of 2, we look at this table value and we have a value of 3. So that means that f of g of 1 equals 3. Next, we have g of -1. So we'll start with our inner function again. So g of -1 gives us 2. So that means if we're looking at g of -1, what we're really looking for is g of 2. So look at 2, that gives us 5. So g of 2 gives us 5. So that means g of -1 is equal to 5. We can also utilize graphs to solve these. The only difference is we get our values from the graphs instead of table of values. So for example, here we have f of x is a square root function, while our g of x is a linear function. Now we want to find two things. We want to find f of g of 2 and g of f of -1. So I'll start with my inner function on this first one. So g of 2, here's our graph of g of x. At 2, it is at 0. So if we're looking for f of g of 2, what we're really looking for is f of 0. So f of 0, here's our, so that'd be right here, so that'd be 1. So f of g of 2 just gives us 1. Now if we have g of f of -1, we'll find our inner function first. So f of -1, so that would be here at 0. So that's saying if we have g of f of -1, that's the same as saying g of 0. So now we'll look up what g of 0 is. G of 0 is this point here, so it is at positive 1, 2, 3, positive 4. So therefore we can say g of f of -1 is positive 4. Now we can determine the composite functions algebraically by substituting a known value into the inner function, solving, and then inserting the value into our x and our outer function. For example, given f of x equals x squared plus 3x and g of x equals -2x plus 1, we're going to find what g of 9 is. So our inner function is g of x is equal to -2x plus 1, we want to find g of 9. So if we're looking for g of 9, that'd be negative 2 times 9 plus 1. So g of 9 is negative 17. Now we'll do our outer function. So we know our outer function is f of x is equal to x squared plus 3x. So we'll now substitute that 17 in for our x's. So we've got f of 17 is equal to, negative 17 is equal to negative 17 squared plus 3 times negative 17. And that gives us f of negative 17 is 238. So overall, f of g of 9 is equal to 238. Writing the equation of a composite function. To do this, we substitute the inner mathematical function into every place in the outer function that has an x. For example, given f of x is equal to 2x squared plus 1, and g of x equals 2x plus 7, we want to find our equation for f of g of x and for g of f of x. So this first one, we'll write out our outer function first. So we've got f of x is equal to 2x squared plus 1. And then our g of x is getting inserted into it. So that's really going to become f of 2x plus 7 equals 2 times 2x plus 7 squared plus 1. Next, we'll want to expand this out. So we'd have 2 times 4x squared plus 28x plus 49 plus 1. Then we'll multiply out correct right terms. So 2 times 4x squared is 8x squared. 2 times 28 is 56. So we've got 56x. 2 times 49 is 98 plus 1 gives us 99. So our f of g of x is equal to 8x squared plus 56x plus 99. Okay, so we'll do a similar thing with this one. So we'll start with our outer function. So we have g of x is equal to 2x plus 7. Now we're substituting f of x into it. So it becomes g of 2x squared plus 1, because that's what we're substituting in for our x's. So we've got 2 times 2x squared plus 1 plus 7. So we have g of 2x squared plus 1 equals 4x squared plus 2 plus 7. So that gives us g of 2x squared plus 1 is equal to 4x squared plus 9. So we can write it as g of f of x equals 4x squared plus 9. Now, if f of g of x is the same as g of f of x and equals x, that means that the two equations are inverses of each other.